Welcome back. We have another challenge in the 7 Caillou series. This one's called Largest 5-Digit Number in a Series. In the following 6-digit number, 283910, 91 is the greatest sequence of 2 consecutive digits. So you can imagine starting at the left there, take 2 at a time, you would have 28. So, okay, that's the first largest. Then you take the next 2 numbers, 83. Oh, 83 is bigger, so now 83 is the max. Grab 2 more, 39. Nope, 83 was still bigger. Then you get to 91, which beats 83, so that is the biggest. And then finally 10, which is obviously lower. So that's how they got the 91 is the greatest. And the following 10-digit number, pictured here, 67890 is the greatest sequence of 5 consecutive digits. And I think that's pretty easy to see. Complete the solution so that it returns the greatest sequence of 5 consecutive digits found within the number given. The number will be passed in as a string of only digits. It should return a 5-digit integer. The number passed may be as large as 1,000 digits. So that's a pretty large number, right? But the instructions are good. They are clear. So go ahead and give this one a shot. You know the drill. Pause it, crank it out, give it your best shot, and come on back. So we will get into it. Notice in the example they, to first explain it, they used a simpler idea with only 2 digits. But we know in our challenge it's always going to be 5. That's sort of fixed. And when we have something like that, that's the case, I like to create a constant for it. Read only. So I'm just saying an integer here, I'll call it num digits, and it's always going to be 5. And so I can refer now to this variable name instead of having weird 5 values around the code. Hopefully that makes sense. It makes sense. 5 isn't confusing to us because this problem is so small, but if you came back a long time from now or showed it to somebody else, your code, they would probably wonder, why are you doing this stuff with 5? What's the big deal with 5? And so it's just a nice way of giving meaningful names to things. And then if we ever changed it, I can just come to this one place, change it to 4, and then bam, my whole code responds accordingly and is ready. But anyways, we're on 5, so let's do that for a handy reference. I like to get into that good habit even though these problem sizes are small, because it'll help you when you get to bigger problems. So next order of business, they basically guaranteed us that it will only be digits in the input. In a real world scenario, you'd probably want to scan this string and you could check the characters that they were in fact numeric values and nothing else. I'll leave that be here, but if you want to go the extra mile, you can go ahead and do that. One edge case I'll consider is, imagine if the string size was less than 5, right? So we'll handle that. What would we do in that case? Well, greatest sequence of 5 consecutive digits, I'm going to go ahead and interpret that as I'm just going to return 0. There's not a 5-digit number there, and I'm assuming the work doesn't apply to numbers that are less than 5 digits. In a real life scenario, of course, you get these edge cases come up. You would go talk to somebody who knows how the program should work, and you can ask them, hey, what about 4 digits? And they'll tell you, don't worry about that, and then you could throw an error or do whatever you want for that case. Whatever is appropriate for your situation. But let's check it here. If string length, strings have a length property that tells you how many characters are in them, if it's less than, and we already have this new constant here, if it's less than the number of digits, I'm just going to return 0 right away. Then I skip, because as you can imagine, I'm going to sort of scan the string and do some processing. And if we're less than the number of digits, I don't even want to reach that part of the code. I'm just saying, hey, all bets are off. This is unexpected input. I'm out of here. Okay, so now we're below that. We know that the string is valid. You know what, actually the way I might choose to handle this, I might just say instead, instead of just saying 0, I'm just going to give them back the number they gave us. And that way I can expand this a little bit more to be less than and includes, right? Because if it's a 5-digit number exactly, there's no scanning to do, right? The 5-digit number is the only possible answer. So we can just return it. But remember, our contract says, I like to think of methods as contracts, it says, hey buddy, you got to return an integer. So we got to be sure to do that. And I think we've converted strings to integers in the past. If not, you're going to want to look up the IntegerParse method. And I believe there's a try-parse variation too that can possibly help you if the string isn't in a numeric format. You may also see this written as int32parse. Whatever one you like. I don't think it matters which one you use. But this basically will say, hey, just return the input as an integer, just as is. Okay, so I like that a little bit better. Now we'll get on to the processing. So I'm going to create a couple local variables to help us. You can imagine when I first walked through that first example there, I was kind of grabbing 2 numbers at a time, and then I was sort of in my own head, in my memory, keeping track of which one I encountered that was the largest. So I want to make this max variable, and that way I'll keep updating it every time I find a bigger value. And then by the end, it'll be the highest value. Okay. And then we're going to loop over the string, and we're going to scan the characters. I'm going to use a for loop for this. And you can imagine too that we don't need to scan all the way to the end. So consider this larger example over here where they give us 10 digits, right? Once as I'm scanning, I'm going to take the first 5 numbers, then I'm going to take the second group of 5 numbers. At some point, I'm going to get to this 6, 7, 8, 9, 0, and then I'm going to be done. Notice that I don't have to keep going 7, 8, 9, 0, 8, 9, 0, 9, 0, right? So once you hit the length of the string minus the size, the number of digits that we're checking for, we know we're done. So I'm going to cut my loop short there. You could keep going, but it's just extra processing that's not going to find a max for you. So I like to try to be efficient where I can be. And we're going to less than that, and then we can plus I. So yeah, we're starting at that first index there. We're going to grab, that's kind of where we're looking to start, because we started at 0. And then I'm going to make another sort of local variable here to store the current value. And for max, I just initialized it to -1. You could have used the lowest possible integer. I just basically wanted to, I was worried about the case maybe where I got 0 as a number and I didn't want, I don't know, you might even be able to use 0, but just something low such that it's going to be lower than the first thing you encounter. And so that could raise another question about input here. You know, is this string, it said it only had digits in it, so it should be positive. You know, if it weren't, then one of the characters would have to be a minus sign to denote a negative. So I think we're safe to say that the input is positive so long as they adhere to their own rules. But you could scan for that too. That'd be really good. So anyways, that's my assumption. And then I just got this other one because at each step through the loop, I want to sort of calculate a value of what number I have at any given time that I can compare against my max, right? So let's do that. I suppose the first thing to do, string, we'll call it num, is we got to get, for number, we've got to get the current 5-digit number based on where we started. And with strings, we know we can get what is called a substring. It's a portion of the entire string. You can specify indices to pull out apart from the beginning, apart from the end, apart from the middle. And so we'll use the string class's substring method to do this. Very useful. Look it up if you don't know it. And so my lower bound there then will be I, right? It'll be 0 to start, but as we increment, it'll go up to 1, and we want to start from 1. And then it will always be the second argument to substring is the number of characters you want to read. And so we're always reading 5, right? Num digits. So again, this constant is coming in useful. We're able to refer to it in multiple places. Okay, so we got that. At this point, you have a number. It's still in string form, but instead of a large input up to 1,000 characters, now you've got the 5 that you're examining at any point. So good. Next step, though, we got to convert that into an integer form, right? So I can say, the same idea that we used on our edge case. We can say current equals int parse num, right? And that's just making that conversion for us from string to integer. And then it's time, we got to do our comparison, right? At each round, I checked in my memory against the known highest. When you first start, there is no highest, so this value is meant to depict that, so it will automatically be beaten by the first value you encounter. So if current is greater than max, which it will be the first time around, max equals current, right? You found a new max and you set it, and then your next check will compare against that value. And you can imagine how this would proceed on then. I would go up to 1, you'd grab 2, 3, 4, 5, 6. With this substring call here, you got that string, you convert it to an integer, same thing, but not with double quotes around it. It's an actual numeric value. And then you're comparing 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5. Obviously that one's bigger. Max gets updated to 2, 3, 4, 5, 6. You hit the end of this scope right here for your for loop. And so it comes up again and it updates, right? Plus plus I, now I is 2. It's going to say, hey, get me the substring from index 2 and grab 5 digits. So 0, 1, 2. It's going to grab that 3, take 5 digits, 3, 4, 5, 6, 7. It's going to come down here, knock the double quotes off, make it a number. It's going to compare 3, 4, 5, 6, 7 against 2, 3, 4, 5, 6. And obviously the max is going to get updated again to 3, 4, 5, 6, 7. And that process will continue until we get to that index 10 minus 5, the 5th index. So at that point, though, we've gone entirely through the loop and we can simply return our max. It should have, we've processed everything, we're ready. So I think that covers it. I'll go ahead and give it a test. Okay, we failed. Let's see what we did wrong. Test pass. Non-overlap test expected 74765. Let's take a peek at those tests. Here's the non-overlap test. Get numbers. Oh, okay. Yeah, I see the problem. So they were expecting this answer, right? And I agree with them. They were right. You can see it here. That would be the biggest value. That would certainly be bigger. And our problem is, you can imagine that, look what we returned. They're expecting this. This is what we gave them, 73167. 731. So it's pretty clear that it just never reached the end. And that's common when you're doing loops. You might be off by 1. And I think I came up just a 1 index short there. So let's change this to less than or equal to, and that will cover us and get us so that we're examining the whole input. So in that case, what's the string length there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Num digits is 5, so it'll get us up to index 4, which should be the 5th number. 0, 1, 2, 3, 4. Yep, that's 7. That'll make sure we get up to index 4 as well. So I like that better. Let's go ahead and test. Good green. And of course, you can add your console statements here, print what num are and current here. You could add a line in here to do that, just so you can watch the program sort of executing, and that can make things clear too if those test statements aren't quite giving you the information you need to figure out what's wrong. So I'll hit the larger suite. Let's go. Good, still green. So yeah, I'm gonna leave mine like this. I'm sure there's a lot more concise answers out there, and we know what to do. Submit, get those hard-earned honor points, and check other solutions for cool ideas. More things to put in the tool belt, right? There you go. It's a nice one-liner for you. S length is for cool, leveraging some link methods there. Same kind of thing going on. That seems to be pretty popular. So yeah, if you haven't seen these, definitely check it out, or you might get some ideas like, whoa, what's this kind of syntax, and then you type that into Google and go look it up. Pretty common. I did mine the old-fashioned way. Sort of roll your own. That's kind of cool, doing some error checking there. But yeah, have fun, knock yourself out. You know what to do if you have questions. Hit me up in the comments. I appreciate all the likes. Thank you very much, and I will see you in the next one.